Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the problem solving section called the binary search tree lowest common ancestor. And for this particular challenge, the description says you are given a pointer to the root of the binary search tree and two values of v1 and v2. We need to return the lowest common ancestor, which is LCA or least common ancestor, of v1 and v2 respectively in the binary search tree. And for this particular challenge, we are using Java 7 as our language. If you want to use something else other than Java 7, then go ahead. I encourage you to do so. And we have the LCA function right here, which is expecting a return of node. Since it is a Java 7, then expecting a public static function called the LCA. And then that takes three parameters. The first one, which is the root node, which has the closed node right here as listed, which has the property of the data. The next one should be the left, which is another node chain with another node. Let's say we have the parent node, which is 2, and the left node should be the node 1 right here. And also on the right node is supposed to be node 3. And for the second parameter, which is the v1, which is the data that we need to compare against the current node with its data property. So if it's true, then we need to return that node recursively to the parent node. And using the next one should also applies on the same thing. It acts the same thing as the v1 right here that we have to work here. And this is the rough visualization of the binary tree, which is the parent node has the node of 2 and the left node is 1, the right node is 3, and 3 is the parent of 4 and 5 respectively, and then finally 5 is the parent of the only node, which is 6. I don't know which side 6 is on. It's either on the left or right, but it is only one parent, which is 5 right here. And in the diagram above, the lowest common ancestor of the nodes 4 and 6 is the node 3. So node 3 is the lowest node, which has node 4 and 6 as the descendants. So in order to find the, let me explain this. In order to find the, let's say we have the node 4 and 6, and what we need to do is we need to find the common parent of the node 4 and 6, which is the shortest parent possible. Let's say 4 has the parent of 3 and 6 also has the parent of 5. Then where 5 is going, 5 is a descendant of the node 3, so we need to return 3 because 3 is the shortest parent possible between 4 and 6 respectively. So 3 is going to be returned as our answer in a form of a node right here as expected in the function. And the function description, we have the completed function LCA in the editor below. It should return a pointer to the lowest common ancestor node of the two values given. So without further ado, let's solve this out. For the first one, we need to check for the store the left and right node respectively. We need to declare variable called the node, which is the left node. You might want to use left or just left node. Go ahead, I encourage you to do so, and we can just call this recursively using the LCA, calling the function itself. Of the LCA, we can just call the LCA function inside of its function, passing the root, you guess it, using the left property, because this class node has the left node as the property, so we can just passing the root.left as the first parameter, and the next parameter we can just pass the v1 and v2 respectively for the second and third argument or the parameter. And the same thing also applies on the right node, which is on the right node, and we can pass in the LCA function again, pass in the root, right, and then v1 and v2. So because we are working this recursively, then we need to work this from the bottom, write the code from the bottom all the way up to the top instead of the usual flow from the top to bottom, because it is calling the function itself over and over again. So for the next one, we need to check if both nodes are not null, which is we need to expect at least if either one is null, then we need to return the only node that is not null. If they are both null, then we need to return null as it is. If they are both returning left and right node without null at all, then we need to return that as the parent, which is on the current root that we are currently accessing on. We can just pass in if the left node is not null using the exclamation mark and the equal operator. Check if it's not null, and with the AND operator, the right node is also not equal to null. It's not null, then if they are both not null, they are both has the value of node, then we can just return the root, which is passing as the parameter as the returning answer. And for the first one, okay, so let me explain this again. Let's say for the first one, the v1 right here, we need to return this one and also returning the v2, which is 7. This is v2, and the first one, which is v1, and which one is the parent of both 1 and node 7. So let's say we are recursively accessing from the parent node, which is the root node of the 4, and we can go to the left, accessing the left property, which is the left node right here, and we're accessing 2, recursively calling it again, and then we are accessing 1. Since 1 is found within the both arguments of the v1, either v1 or v2, then we need to return that because we finally found the right node that we are looking for. So we need to return v1 as the node onto the node 2 right here, and the 3, since 3 is not the requirement from the v1 and v2, then we don't return 3 at all. So for the node 2 right here, we have 1 and null, so we can just return 1 right away to the top. And for the 7 right here, since we are already accessing right, then we need to return 7 because 7 is found on the v2 parameter, because we are passing on the right node with the first one, which is the root dot right, accessing the right property, and it is fulfilling the data with the v2 right here, v2 value. Then we can just return it as it is, which is the node 7. And then since they are already meeting on the parent node 1 and 7, then we can just execute this if check. If the left node is not null and the right node is not null, then we can just return root right away as the answer. So 4 is the LCA, or the least common ancestor. Okay, so we already cover all of the essentials right here on our code, and the next thing we have to cover is the edge case. For the next one, we have to check if the current root is equals to null, adding an edge case. Check if it is null, then we can just return null, and we can just add another check if the root accessing the data property of the data is equals to the either v1 or root.data, either v1 or v2 is equals to the v2 value. If it is, then we can just return the root node to the top of the parent that already called the left node and right node recursively. So what if we are just returning either 1 right here from the node 1, and we are not returning 3 to the top from the, since we are accessing node 2 right here, currently accessing node 2, we can just returning 1 to the 4. How do we do this? Is by adding an if check on the last part of our code. If block, if the left node is not equal to null, if either is not null, since both node already covered right here as the returning root, return as root. If it is just either one of the node, either left or right, then we can just return the left node right away. Return left node as it is. And finally, if only the right node, the other way around, opposite of the left node, it is the same thing as the if check. If the right node is not equals to null, then we can just return the right node. Since the left node already covered, then we can just passing the return right node right away. And we can just run our code to see if it works. And we have 3 sample test cases already covered. And let's submit this to see if it really works. Okay, so everything is success, Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.